We have all seen the movies. A glowing, metallic android glides through a neon city, thinking, plotting, and acting with human grace. Then you go home, ask your smart speaker to set a timer for pasta, and it plays heavy metal music instead. It feels like a far cry from that science fiction dream. The label artificial intelligence actually describes a broad range of different technologies, each sitting at a very different stage of evolution. To make sense of it, computer scientists categorize AI along two distinct tracks. One is capabilities, which measures what it can achieve. The other is functionality, or the way its digital brain processes information. Judging AI on these two separate tracks explains exactly why your smartphone can flawlessly map the unique contours and curves of your face to unlock your phone, but still fail to detect human sarcasm. Let's look at the capabilities track first. Every single piece of artificial intelligence in the world today, from your smartwatch to massive corporate data centers, sits on the exact same starting rung: narrow AI. Think of narrow AI as a highly specialized worker. It is trained and programmed to perform one specific task, and it does that single job with extreme proficiency. Your phone's digital assistant is a classic narrow AI. It is restricted to its programmed fields, like recognizing speech patterns or searching the web for weather forecasts. But because it is so specialized, it has strict boundaries. If you force that same assistant to diagnose a medical symptom or write a novel, it will fail unpredictably because it lacks the programming to operate outside its specific training area. The next theoretical step up is general AI. This is a system that could sit down and perform any intellectual task efficiently, adapting on the fly just as easily as a human being. Beyond that is the ultimate hypothetical goal: super AI. At this level, machine thinking abilities, the capacity to reason, plan, and solve puzzles, would actually leave human intelligence behind. Because our current technology is strictly narrow AI, it remains highly specialized. It lacks the broad, flexible adaptability we associate with human intelligence. Now let's pivot to the second track: functionality. To see how these machines actually think, we start with basic, reactive machines. A reactive machine works entirely without memory. It simply observes what is happening right now and reacts with the best possible move. It doesn't store past experiences to help it make decisions in the future. Famous chess-playing supercomputers work this way. When it is their turn, they calculate millions of current board possibilities, but they do not store previous matches to inform their future strategies. To find the cutting edge of the technology we use every day, we move up to limited memory AI. This car uses limited memory AI to store a small amount of past data. Like recent Instagram shows, this memory is short-term, constantly deleting old data to make room for live information. That short, rolling timeline of data is exactly how these vehicles perceive their environment and safely control themselves on open roads. Understanding limited memory demystifies everyday AI. When your navigation app updates a route, it isn't truly learning like a human. It is simply referencing a short-term timeline of data points. Looking toward the future of functionality brings us to the next theoretical leap. This would involve a machine being able to sense how you feel, understand why you believe something, and interact with genuine empathy. This capability is known as theory of mind. The final milestone for how machines process information is self-awareness, a state where they develop their own consciousness, feelings, and internal motivations. It is important to remember that both theory of mind and self-aware AI do not exist in reality. They remain entirely hypothetical. The emotional, scheming robots from blockbuster movies require these non-existent levels of functionality, keeping them strictly in the realm of fiction. By bringing the capabilities and functionality tracks together, we can finally see where the technology in our lives actually sits. Almost every piece of modern AI technology sits right here, at the intersection of narrow AI and limited memory. The conscious androids from our sci-fi dreams are a combination of general AI and self-awareness, two rungs of the ladder we haven't even reached. Even massive, world-famous supercomputers that solve complex problems are, under the hood, still just highly advanced narrow AI. The next time a streaming algorithm makes a bizarre recommendation, or your phone misses a voice command, you can set aside any fears of a robot uprising. You are just looking at a narrow AI with a limited memory, doing its best.